When a crisis hits, we always see the flashing lights, the heroes on the ground. But what we don't see is this invisible system working behind the scenes, a hidden network that can literally be the difference between life and death. So today, we're going to dig into how investigators and first responders actually talk to each other when everything is on the line. I mean, really think about that. A major incident goes down, and suddenly thousands of people are all trying to use their phones at the same time. What happens when a detective needs to send critical photos from a crime scene, or a paramedic needs to talk to the hospital, like right now? Do they just get a busy signal? And this isn't just some what-if scenario. It really happened. During the horrific attacks in Madrid and London, the public cell networks, the ones you and I use every single day, they just collapsed. They were completely overwhelmed. At the exact moment they were needed most, they were gone. Okay, so let's get into why this happens. Because once you understand why our everyday networks can fail so spectacularly, the solution starts to make a lot more sense. Here's the simple, kind of brutal truth. The networks our phones run on, GSM or 4G, they're businesses. They're built for commerce. They're designed to make money by putting cell towers where the most people are. They just aren't built from the ground up for the insane life-or-death demands of public safety. So let's break down the weak spots. They've got patchy coverage in remote areas, which is a huge problem if a crime scene is out in the middle of nowhere. They get overloaded in a heartbeat during any big event. A lot of them don't have things like battery backups, so in a blackout, they're useless. And here's the kicker. They can't guarantee that a police officer's call will get through when a million other people are trying to call at the exact same time. So, if you can't rely on the public system, what do the pros use? Well, they use their own dedicated private network, one that's built for a single purpose, to work when absolutely nothing else does. Let's talk about Tetra. So TTRR, it stands for terrestrial trunked radio, is basically the European standard for professional-grade mobile radio. Just think of it as a communication system built from scratch, just for organizations like police and fire departments. It's secure, it's reliable, and it's completely separate from all the chaos on the public networks. This is probably the best way to think about it. A public network is like a public street. It's open to everybody, which means it gets totally gridlocked during rush hour. Tetra, on the other hand, is like a private highway reserved only for first responders. No matter how bad the traffic jam gets on the public roads, their highway is always clear. And this private highway comes with some serious superpowers. A detective can talk to her entire unit at once, like a superpowered walkie-talkie. Calls connect instantly, no lag. Critical calls always get priority. And this one is huge for investigations. It has end-to-end encryption. That means no one can listen in on sensitive crime scene information. So, awesome. Problem solved, right? The perfect, super reliable network for first responders. Well, not so fast. Because just as technology solved one huge problem, the world went and created a brand new one. You see, Tetra was perfected for voice, for talking. But modern policing, and especially crime investigation, has become all about data. A quick voice call just doesn't cut it anymore when you need to be sharing digital evidence in real time. Just imagine what an investigator needs to do at a crime scene today. They gotta send high-res photos back to the lab right now. They need to check a fingerprint against a national database right from their car. They need to pull up case files from a central server. All of that, it takes a ton of data. And this is where we hit a massive wall. Just look at the difference on this chart. Tetra, for all its amazing reliability, maxes out at around 28 kilobits per second. You see that tiny little bar? That's basically dial-up internet speed from the 90s. Meanwhile, even a basic 3G or LTE connection on your phone is giving you over 1,000. It's not even a fair fight. So here's the big problem we're facing. The very system that was designed to be a lifeline is now, in some ways, a bottleneck. That super reliable private highway, it was built for cars, but now everyone's trying to drive massive data trucks down it, and it's just too slow. So what's the move? Do you just get rid of the reliable private highway and force everybody onto those public roads that we know can get gridlocked? No way. The real future is actually way, way smarter than that. The answer isn't about replacing one thing with another. It's about integration. It's about building a hybrid super network that cleverly combines the best of both worlds. You take the rock-solid reliability of the private network and you merge it with the incredible speed of the public one. So here's how you build it. First, you keep Tetra as your reliable core. That mission-critical voice, that one-to-many communication, is just too important to ever get rid of. That's your foundation.
Then, step 2, you layer on the commercial broadband networks, like LTE, to act as your high-speed data pipe. An officer's device can be smart enough to automatically use LTE to send a big video file, but then use Tetra for an urgent voice call. It's about using the right tool for the job. And third, for the absolute worst-case scenario, you have an incredible fail-safe.
And that fail-safe is this amazing thing called a mobile ad hoc network. Basically, it's a temporary network that the devices of rescue workers create themselves on the fly without needing any cell towers or infrastructure at all. If an earthquake or a hurricane wipes everything out, the devices themselves literally become the network. How cool is that?
And look, this whole hybrid approach, it isn't just some idea on a whiteboard. We've already seen powerful, real-world examples of how using every network you can get your hands on saves lives.
Take the 2011 earthquake in Turkey. The public cell network actually came back online. A young man named Yalçın Akay was trapped under the rubble of a collapsed building, but he was able to use his cell phone to call the police. Because that call got through on the public network, he saved himself and 3 other people who were trapped with him.
And in that exact same disaster, something even wilder happened. A search and rescue team actually used location data from Twitter to find 3 more trapped people. I mean, just stop and think about that for a second. Twitter, a public social media app, became a critical, life-saving tool in a disaster zone. And that right there is the big takeaway. The future of communication for our first responders isn't about finding one single perfect network. It's about having a smart, flexible, hybrid system that can use the best tool for the job at any given moment. Whether that tool is a high-tech police radio, a regular old cell phone, or, even a tweet.
It just goes to show you that our safety depends on these incredibly complex, hidden systems all working together. And it really makes you wonder, doesn't it? In the next crisis, when every single second counts, what's our lifeline going to be?